Get ready for a mind-blowing idea. You could literally be immortal. I know it's not exactly what we think of when we imagine living forever, but hear me out. We all know that our bodies are made up of tiny building blocks called atoms, and the craziest part is that these atoms will stick around even if your body doesn't. But don't get too comfortable. There's a cosmic force about 150 million kilometers away that has the power to wipe out every single one of those atoms. Can you guess what it might be? You think you've got this immortal thing figured out, but hold on to your seat. Let's talk about what would happen if you somehow made it to our star, the Sun. I know, it sounds like science fiction, but bear with me. To get there, you'd have to break free from Earth's gravitational pull and start a journey that'll leave even the fastest space shuttles in the dust. Right now, we're cruising around the Sun at 67,000 miles per hour. Think of it as one long, cosmic fall. The Earth's rotation is just another direction for us to plummet towards our radiant star. You might not feel like you're falling when you're zooming around Earth at breakneck speeds, but that's exactly what's happening. You're in a state of continuous free fall towards our planet. Same goes for your spaceship if it's hitching a ride on Earth's rotation. To make a beeline to the Sun, you'd first need to shake off the Earth's gravity and find some serious space to maneuver. You'll have to get at least 1 million miles away. That's almost 4 times farther than the Moon is from our home planet. Once you've cleared this massive hurdle, you can start thinking about stopping your spacecraft's rotation. But we're just getting started on this sun-bound journey. Buckle up and let's talk spacecraft. Some heavy hitters like the Atlas EAs or Falcon 9 can give you a serious boost, helping you cover that million-mile gap from Earth. And with rocket engines like the RS-60, 8 or Merlin 1D on board, you'll be able to slow down from a mind-boggling 67,000 miles per hour to a dead stop. But don't get too comfortable. It's about to get crazy. As soon as you've stopped, you'll start accelerating straight towards the Sun at an insane rate. By the time you hit the Sun's surface, you'll be zooming along at a blistering 384 miles per second, or 618 kilometers per second. It takes about 65 days of free falling to reach this velocity. That's a wild ride we're talking about. Let's break down the first 64 days of this epic journey to the Sun. If you've got a spacecraft equipped with some serious heat and radiation protection, like a carbon fiber shield similar to what NASA used on the Parker Solar Probe, you're golden. This shield will keep the interior at a comfy room temperature. We're talking around 84 GF or 29 C. Even as the outside temp shoots up to a scorching 2,500 GZF or 1,370 degrees C. That's some serious heat resistance right there. But here's the thing, just 4 hours into your descent, things are about to take a drastic turn. The shield will hit its limit, and things are gonna start getting really hot. But hold up, there's a massive catch. The Sun's magnetic field is like a giant oven, blasting its outer atmosphere to an insane 2 million degrees Fahrenheit or 1.1 million degrees Celsius. And since we're in space, the lack of air means that even at a relatively cool 10,000 degrees Fahrenheit, 5,540 degrees Celsius, your spacecraft's protective shield would vaporize, incinerating everything inside, including you. After that, your remains would get tossed into the solar corona, where they'd be cooked to a sizzling 2 million degrees again. The result, you'd be transformed into plasma, the fourth state of matter, and basically just a superheated gas. Not exactly the most pleasant way to go. But wait, it gets even wilder. The Sun's magnetic field wouldn't just incinerate you. It would also stretch and distort you like a strand of spaghetti, twisting and bending you into an arc of light. And here's the crazy part from space. Earthlings might actually be able to spot this spectacle using a telescope aimed at the Sun's. Just don't forget your special solar viewing gear by. Now, as plasma, you'd have a chance to make the journey back home, but only after being broken down into tiny particles. Once that happens, the Sun's magnetic field would kick those particles back out into space at incredible speeds, allowing them to cover 100 million miles, that's almost 150 million kilometers, and return to Earth in just a few short days. So, if NASA wanted to turn someone into plasma, they could basically send them on a solar joyride. It's like a space-age game of cosmic ping pong. Let's fast forward to a sci-fi scenario where your spacecraft has an insane upgrade. a heat-proof shield that lets you dive deeper into the sun's atmosphere. As you breach the surface, temperatures plummet from scorching hot to just 10,000 degrees Fahrenheit, (so 5,540 degrees Celsius. With your protective coatings still intact, get ready for a mind-blowing first. You'll start to hear things. And I'm not just talking about your own screams echoing through space. In the vacuum of space, sound doesn't exist, but on the sun's surface it would be like being right next to a revving motorcycle engine. No special gear needed, just your ears die as if they could handle the intensity. Alright, buckle up, we're diving even deeper. If you somehow manage to withstand that ear-shattering sonic boom on the sun's surface, you'd be in for a wild ride. With extreme soundproofing, you'd make your way to the sun's core, where conditions are off the charts literally, like nothing found on Jupiter, let alone Earth. The key difference between our star and gas giants isn't chemistry, but sheer size of the sun is an astronomical scale bigger than Jupiter. This means temperatures and pressures are so extreme that nuclear reactions ignite, making it a thermonuclear furnace unlike anything else in our solar system. You're not just visiting the sun's core, you're literally merging with it. Temperatures soar past 7 million degrees Fahrenheit or 15 million degrees Celsius. That's hotter than the hottest fire we can imagine. And to make matters worse, the pressure is crushing, 250 million times stronger than Earth's surface. For us humans, this is a recipe for disaster, since our bodies are mostly made up of hydrogen. At these extreme temperatures, those hydrogen atoms start moving at incredible speeds and collide with each other nonstop, producing deuterium and tritium isotopes. Then, in an unstoppable chain reaction, these isotopes combine to form helium nuclei, and if you're not careful, you'll become a walking, talking hydrogen bomb. Hold up, let's flip some script here, you're a tiny human. But don't underestimate your inner nuclear powerhouse. A person can produce more heat relative to their size than our star, the sun. It all comes down to mass. While the sun is gigantic and produces massive energy output, if you were the same size as it, just eating your usual meals and digesting food would make you the hottest star in the galaxy. Now, let's geek out for a second. Einstein had a famous formula that can shock you into understanding human power. It goes like this: when we convert just 1 gram of stuff, that's about 0.03 ounces into energy, we release an equivalent blast to the infamous Nagasaki atomic bomb from 1945. That's some mind-blowing, everyday nuclear potential right there. Let's big explainer some numbers and blow your mind. If we take about a kilogram, 2.2 pounds of stuff, we're talking roughly 25 billion kilowatt hours of energy. That's equivalent to an average person weighing around 70 kilograms as 154 pounds, unleashing more power than the entire US. Coal industry produces in just 1 year when their atoms are split. Talk about a human nuclear reactor. Now, multiply that by every single person on Earth. It's mind-staggering energy potential. But let's be real here. There's no way to safely tap into all that atomic oomph without causing some serious cosmic chaos. So while we humans might have the power of stars within us, when it comes down to it, our star in the sky remains the most reliable way for a potentially disastrous atomic showdown. Now, while harnessing our inner nuclear reactors for destruction might not be the most practical or humane approach, there are indeed other ways to explore, albeit less exciting ones, like nuclear bombs, particle accelerators, or any intense source of radioactive radiation. However, keep in mind that using these methods would lead to a prolonged and painful demise, which isn't exactly something we'd wish upon anyone. On a more fascinating note, scientists are planning to take apart the human body at its most fundamental level, turning us into separate atoms. But don't worry, this won't be for any destructive purposes. This technology is actually aimed at making teleportation a reality. The idea: to move your entire being from point A to point B, atom by atom, in an instant. Sounds like something straight out of science fiction, right? Well, according to the minds behind this concept, physicists from Imperial College London and the University of Glasgow, we might see this technology become the norm by 2080. If you'd love a deeper dive into teleportation or atomic disassembly, hit that comments button below and let us know. That's all for today's video. A massive thank you to each and every one of you who made it this far exploring the weird and wonderful world of atomic destruction, teleportation, and beyond with me. If you're as excited about these mind-bending concepts as I am, be sure to give this video a big thumbs up, subscribe to our channel for more edutainment awesomeness, and hit that notification bell so you never miss out on new releases.